As John mentioned, I first met John when I was a student at the University of Colorado, and he was a professor there. And then, since I came to the lab in 1981, just shortly after John did, he's been a great mentor, collaborator, and friend over these many years. So, for that reason, it's really a great privilege to be participating in this symposium. And I look forward to these many interesting talks spanning John's career and John's interests in different areas of physics and astrophysics. So our first speaker this morning will be Carol Alonso. Carol got a PhD in nuclear physics from MIT. She taught at Yale and worked at the Berkeley lab for a while. While at Berkeley working with Glenn Seaborg, she co-discovered an element, number 106. She started at Livermore in 1975 and has served in numerous management positions, including leading and founding the Rodeo program, into which John started to work. She was Deputy A Division Leader, Assistant to the Director, and Associate Director for National Security. She retired in 2001 to pursue many of her other interests and true talents, and such as horses. I mean, she trains and rides horses. She's done a lot of yachting, painting, writing, and exotic travel, a number of things. So we're really looking forward to hearing her talk. She's going to talk about times of change.
All right. Good morning, everybody. Can you hear me? Yes. I'm really glad to be here to celebrate John's retirement. Hello, Melissa. Hello, John. I thought that since I hired John into my Rodeo group in 1981, that I would go over with you some of the events that happened in the laboratory and in the country during his 36 years at the lab. We were very lucky to have John join my research group. Where's this thing? I had put together Rodeo as a program to investigate or to make a better understanding of nuclear weapon physics without the pressures of a weapon development program behind it. So we were focusing on developing analytic tests for the codes and developing experiments to test the codes with real data. This mission had a lot of overlap with astrophysics, of course, and with radiation hydrodynamics. So to build this group, I hired at that time first Richard Klein, then John Castor, and then Richard Ward. Jerry Pomerany, whose picture I couldn't find, was a frequent researcher that worked with us at the time. Whoops. Dmitry Mihalis. This thing is too sensitive. Dmitry Mihalis at Los Alamos worked closely with us. Okay, we got it. Jim Wilson, as an astrophysicist, worked with us on relativistic radiation hydrodynamics. David Dearborn worked with us. So we had a stellar, excuse the pun, set of people working in a Rodeo group in A Division at the time. And out of that group of people came the major textbooks in radiation hydrodynamics. First was Jerry's in 1973. Then Dimitri's when was Dimitri's? 1984. And then John, blast that thing. John Castor's in 2004. John received, as John said, an NNSA award for all his work in radiation hydrodynamics. Now, at the time that I hired John in 1981, I was the chairman of something called the Physics Experiment Advisory Panel. And this was our lab's first real attempt to imagine and define hot dense plasma experiments that could be done in the laboratory and have increase our understanding of nuclear weapon physics. We didn't have NIF at the time, but we did have NOVA, which could produce pretty interesting plasma domains. One of John's first assignments was to contribute to this panel. And I'm pleased to say that many of the experiments that this panel advised have been carried out on NIF with quite a lot of success since then. In January 1981, Ronald Reagan became president. The Cold War was still very much alive at that time. In fact, it became elevated in the early 1980s when the Soviet Union shot down Korean Airlines Flight 007. In A Division, our focus was still on maintaining the stockpile with nuclear tests in Nevada. We were assisted in doing this by our Cray computers, simulations on our Cray computers. In 1981, we did not have personal computers. They were soon coming, but at that time, all our computations were done on several immense Cray computers, which cost $1 million a piece, a lot of money then. I remember we fought each other in A Division for hours of running time at night on those computers. We thought the Crays were amazing, so I am just mind-boggled by Blue Gene and 480 teraflops and $100 million. It's a whole new world. In 1981, we could not even begin to calculate 3D turbulence. So times have changed. Also, in 1981, the first space shuttle, the Columbia, was launched. And IBM actually released its first PC in 1981. In 1984, the first Macs hit the market. And I love this picture of young Steve Jobs. A Division was one of the first big mass buyers of Macs. When John first came to the lab, we had no PCs, as I just said. When I retired in 2001 from the lab, we reportedly had 26,000 Macs doing various chores around the laboratory, which is pretty amazing. Now, in Rodeo, we were all soon working quite hard and long, hard days on an unusual event at NTS called ORCNY, which would address some of the physics issues we had where our 2D codes did not match the data. It also would do some forefront spectroscopy. We would measure the equations of state of hot, dense plasmas, other physical quantities. These spectrometer developments became very useful at the end of the decade in our X-ray laser program, which I'll get to later. This slide is a winter photo of our base camp at Mercury at this site. Since those days are long gone, I thought I'd spend a few minutes describing a day at NTS, and a particular one I remember was John's first trip there, Richard Klein's first trip there, Richard Ward's also. We were like the Four Stooges, I have to say. Let me go on here. We would begin by getting in the lab's propeller airplane at Airway Boulevard and sort of bump our way over the mountains to Mercury. In fact, I remember one time when the windshield on a plane broke, and we had to go 300 feet over the ground all the way over the Sierras to Mercury. You could have heard a pin drop in that airplane. And usually it was full of chatter of scientists and engineers heading off to the site. Once we arrived at the test site and checked in at one of the gates, this is not the main gate, for sure. We would drive old DOE white cars to Livermore's Blue Building, and then to CP, the command post, and then to Ground Zero to work. Driving on the Tippipah Highway at NTS, we'd often hear other team members giving reports on where the Nye County Sheriff was. They'd say things like 1056 on CP Hill heading north. This was because none of us wanted to get a speeding ticket on those long desert roads. Okay. When a shot canister, sometimes with a device, was arriving on site, as in this photo, the whole highway was shut down completely. On John's first trip to NTS, 4 of us got into trouble because I had taken them to see Sedan. This is Sedan. It's an immense crater, 1,200 feet in diameter. It was made in 1962 as part of the Plowshare program, and it's now actually a National Historic Site. Sedan is serene, quiet, rather out of the way. And apparently the overhead police monitors showed 4 people that looked rather scruffy like protesters standing on the rim of Sedan because a police car drove up and chased us all away. On the next day at CP, one of us, probably Richard Klein, suggested we get some exercise by climbing up a nearby hill, which was made of rocks and scree and abandoned mining equipment. So we sallied forth, and by the time we got to the top, there was a helicopter buzzing around us. And that same policeman hiked up the hill, said, "You again." This time he made us all sit in CP while he carefully checked out those 4 crazy physicists. So our major rodeo physics test was positioned on a beautiful desert site at the foot of a mountain. Tom Harper, who many of you remember, was the project leader, and I was the design team leader. And for us, that's what that site turned into. For us on the team, it was an amazing experience because you'd start with a sketch of paper 2 or 3 years ahead of time, and you'd end up with this dynamic 7-story steel tower crammed with instruments and busy with welders and technicians and physicists twiddling things and engineers. Everybody wearing hard hats and everybody telling everybody else not to drop a wrench because you know what was at the bottom of the canister. A circle of data gathering trailers surrounded the tower with many thick black cables going to all the diagnostics that would go downhill with the test canister. Miles of cables. We'd work hard, we'd break for a 68-cent lunch at the Area 12 cafeteria with the miners, and then go back to work. On the last day, this canister would be slowly lowered at least 600 feet down with all its cables attached, and you would just hope and pray that the cables in your experiment would make it to the bottom, filled up with dirt. So at the end of a workday, after hours of toiling at ground zero, we would all return to our dorm rooms at Mercury. Now, this is a very beautiful picture of Mercury, but in reality, it was a sort of rough and tumble assemblage of Quonset huts and cement block buildings and fenced pots piled with mining equipment. But we loved to dine on lobster bisque and steak at the candlelit Mercury Steakhouse, where many members of the team gathered. Richard Ward also introduced us to Earl Crooks, an NTS technical resident who held barbecue parties outside his suite at the Livermore dorm. And we conducted a lot of business at those barbecue parties. So on the morning of a nuclear test, when the data came in, it was a very special day, of course. Tests usually occurred at dawn when the wind was still. The whole site was cleared, totally cleared. The process in the control room on test morning was impressive around a long conference table surrounded by a high wall of TV screens showing every part of the site. People in charge would, one by one, quietly give their professional, very serious, detailed reports on the conditions of the site, the canister, and the weather. They knew the position and the activities of every living creature near ground zero, the wild horses, the antelope, everything. Okay. One time we actually had to hold up a test because a cowboy was riding his horse across a remote corner of the test site. But if all was well, the countdown would begin, equally quietly, 10, 9, 8, etc., 5, 4, 3, 2, 1, ignition. Just like you see these days with NASA flights. We were all watching very closely because it was our test and we had just spent years on various experiments on it. Sometimes we could even feel the test. Now, also on test morning, the whole team of physicists and engineers would gather in the blue building to watch the data come in from those trailers miles away from CP, which held the scopes at the end of those miles of cables. Everyone watched the data come in together. That was a Livermore tradition. Now, you must realize that these scientists have just spent 2 or 3 years developing these experimental designs and their downhole diagnostic instruments, and they only have one chance. In a microsecond, it's all blown up. So either your experiment works or it doesn't. If it's good data, the physicist gets slapped on the back and congratulated, and the team makes him feel good. If no data come, and that happened regularly enough, the downcast physicist is consoled by the team. Now, our Orkney experiment was very successful, but fierce winds of change were blowing, and in 1983, President Reagan made a sea change proposal to ramp down the mad arms race in favor of developing technology to intercept incoming missiles. In this, he was strongly influenced by Livermore's Edward Teller. The media called Reagan's defense initiative Star Wars, and as it progressed, William Broad of the Washington Post actually wrote a book describing what was going on at Livermore Lab. It was pretty strange reading his characterizations of the people we worked with every day. So in the mid-1980s, John and the rest of us turned our attention to STI and the possibility of X-ray lasers. That resulted in sometimes outrageous peer reviews with characters like Lowell would, because Livermore has always had a very strong tradition of peer reviews. I hope it still does. And the reviews in those days of secret projects were very, very intense, sometimes devastating for the person proposing an idea. I think John will remember some of those reviews. A level head like John's was a great asset in preparing such a review. Now, just as an aside, the Cold War did have some dark humor. In the late 50s, The Space Child's Mother Goose was published. It's still available and popular today, as is the well-known ditty, one if by land and two if by sea, and if it's by missile, forget about three. But on a much more serious note, sometimes lack of foresight can result in calamity years later. We once had a Secretary of Energy who believed that only the US weapons labs would be able to run the codes necessary to design a nuclear weapon, because the US could export control the supercomputers that we needed. Overriding our strong objections, the DOE declassified much of our code development in the interest of transparency. Little did they know that in a few years, inexpensive desktop computers capable of quite sophisticated calculations would be available the world over. And in my opinion, today we're paying the price of that error in situations like North Korea. So this brings us now to the end of the 1980s and the huge changes that ended the Cold War. Livermore played a big part in those changes. In 1985, President Reagan and Soviet Union Mikhail Gorbachev met for the first time. The Soviet Union was suffering economic problems, and Gorbachev instituted things like glasnost, which is openness, and perestroika, a reorganization. Need some water. In 1986, Reagan and Gorbachev met again in, Reykjavik, where purportedly Reagan's description of SDI led the impecunious Soviets to bow out of the arms race. Reagan's description was backed up by Edward Teller, and at the lab, we knew that our X-ray laser needed a lot more research than what Edward Teller described as engineering details. And there was some consternation here about what would go on. But on the other hand, the very existence of Livermore's X-ray laser program helped to end the Cold War. In 1989, a series of revolutions peacefully overthrew most of the communist regimes in Central and Eastern Europe. The Communist Party of the Soviet Union itself lost control and was actually banned following an abortive coup attempt in August 1991. And this, in turn, turned to the formal dissolution of the USSR in December 1991. The Cold War as we knew it was over. The 1986 Reykjavik meeting in the shorter term resulted in Reagan and Gorbachev signing the INF Treaty, the Intermediate Range Nuclear Forces Treaty. At that time, Livermore's Bob Barker was the Assistant Secretary of Defense. And he was head of the US team negotiating with the Soviet Union on limiting nuclear tests. Most amazing to us at the lab, Bob announced in 1987 that we would do joint verification nuclear tests at Nevada test site with the Soviet Union. What I remember the most about those strange times was that the Soviet scientists who were given a guest per diem by the USA were transfixed by what they could buy at the Target store in Las Vegas. So, 1987 was a seminal year in other ways. Perhaps the most exciting event was supernova 1987A, which suddenly became visible to our naked eyes on February 23rd. The last supernova visible to the naked eye was Kepler's in 1604, and it occurred in our own Milky Way. Before that was the Crab Nebula in 1054, so these are rare events indeed. Jim Wilson was beside himself with delight, and as his codes started churning away, they led to a realization that this, along with his crony Hans Bethe, I should say, the realization that neutrinos were carrying away a huge amount of energy from these supernovas, something like 80–90%. This has led to neutrino physics being in the forefront today. The mid to late 1980s produced other major events. One was the disintegration of the Challenger space shuttle in just 73 seconds after launch in 1985. This hit me personally very hard because I had collaborated with JPL astronauts on a physics experiment on Challenger in the previous flight. Whispers of the future of the world we now live in also appeared in the 1980s. In 1985, TWA Flight 847 was hijacked by Hezbollah, starting a never-ending and still escalating era of world terrorism. And the internet? When John arrived at Livermore, there was only a military data exchange program called ARPANET. In 1989, Tim Berners-Lee, a British scientist at CERN, invented the World Wide Web. No, it was not Albert Gore. The resulting internet was fully commercialized in the US by 1995. And from there, it has blossomed into the wonder that we pretty much take for granted today. Well, I'm going to have to accelerate here. I'm still in the 1980s, but I need to mention October 17th, 1989, when the Loma Prieta earthquake shook the Bay Area and the lab. It just so happened that I, and probably John, was sitting at an NEDPC conference here in this very auditorium. I was chairing the session, sitting in the front row, and then suddenly this whole auditorium started swaying several feet in both directions. And I stood up. I said, not everybody was from California. I said, this is an earthquake. Everybody please walk out that door. The speaker, who had on a neck microphone, was the first person out the door until he reached the end of his microphone tether. And then over the PA system came, ah! And we gave him a special award at the close of the conference for the most moving presentation. So, okay, I'm going to rush and close now, brushing over a few major events in the 1990s and post-millennium. Most of the important things all happened or started to happen in the 1980s. Let me just run through some other significant things. 1990, the first McDonald's opened in McDonald's. Now that's important. The Hubble Space Telescope was launched. Its optical flaw was repaired by a space shuttle in 1993. And as we've discussed, the Cold War ended at this time. And the Soviet Union was dissolved. That very same year, Iraq invaded Kuwait. No rest for the weary on this planet. It started the Gulf War, and our lab and I personally got quite involved in solving some of the technical problems, such as burning oil wells. In 1991, the Oakland Hills firestorm killed 25 and destroyed 3,500 homes, including some belonging to our own lab people. Our lab firefighters provided such outstanding service that they received a standing ovation in this very auditorium. Well, I forgot something there. 1992, we did our last nuclear test at NTS. This was a voluntary moratorium, voluntary. To this day, still voluntary. In 1993, the World Trade Center was bombed in New York City. A van bomb parked beneath the North Tower, exploded, killing 6 and injuring about 1,000 people. Little did anyone even dream what was going to happen here again in 2001. In 1994, in San Francisco, was the first conference on commercializing the World Wide Web. 1996, President Clinton at the United Nations signed the CTBT, the Comprehensive Nuclear Test Ban Treaty. However, in 1999, the US Senate voted to reject ratification of the CTBT, and it remains unratified to this day. This reinforced the Stockpile Stewardship Program, in which certification of our nuclear stockpile depends solely on the accuracy of our codes and our lab experiments. For researchers like John Castor and many of you here, there's a huge pressure to make sure that everything is calculated correctly. I'm almost done. 1998, NASA announced that Clementine, a probe orbiting the moon, which was designed here at Livermore by Lowell Wood and his group, old group, had found enough water in the polar craters to support a human colony. Now that's important. That same year, Google was founded in Menlo Park by Stanford graduate students Sergey Brin and Larry Page. And can't forget, 1999, Star Wars Episode 1 came out 22 years after the first episode. 2001, the 9/11 attacks, almost 5,000 people killed. Losing my voice. And 4 suicide terrorist plane attacks, which you all know about. An event that will never be forgotten. Yours truly retired from the lab during that year. 2003, the Human Genome Project, for which this lab played a huge part, was declared complete. 2004, Blue Gene L was installed at Livermore and rose to an amazing 480 teraflops. 2007, Livermore lost its University of California contract. The lab had been managed from its inception in 1952 by the university through September 2007. And that collegial umbrella has been sorely missed by many. That's in 2007 also, the first smart iPhone was released. And just think how that has changed the world in 10 years. Now, just to finish up, 3 more events. First, 2009, NIF officially came online, began serious laser target experiments, seeking at that time a successful fusion energy source. 2012, the Higgs boson, theorized in 1964, was discovered at CERN on the 4th of July. And lastly, last year, 2016, LIGO announced gravitational waves resulting from the merging of 2 black holes. They now have seen 3 or 4 similar events already. We're surrounded by black holes. This is 100 years to the year after Einstein predicted them. So I'd like to end with Carl Sagan's stirring words, if my throat lasts that long. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. We are one species. We are star stuff harvesting starlight. I think that's pretty cool. So this concludes my historical sweep through John's 36 years. John has always been an asset to provide critical but courteous review of people's work at this lab, and I'm sure you will all miss him, but he's not moving away. And John, I wish you an easy path to your other life dreams in your retirement. And thanks very much, everybody.